So I'm addicted. I'm not afraid to admit it, I just need another fix. And it's Breaking Bad that's got me completely hooked. It's a fantastic show. I know I'm late to the party, it's been on TV for 5 years or so now. In fact, the whole series is finished in the USA. But it's an absolutely brilliant creation from Vince Gilligan, acted out by Bryan Cranston and portraying a chemistry teacher's descent. And this is a chemistry teacher who gets a diagnosis of terminal cancer. He has no money, he can't afford the treatment, he has nothing to leave his family, and so he turns to making crystal meth, using his chemistry skills to make himself some money. It's a brilliant show. Not only is it fantastically acted and wonderfully put together, it looks beautiful, but the chemistry in it is really, really good. They had really good chemistry advice from Donna Nelson, who volunteered to be a consultant on the show. She's a professor at University of Oklahoma, and so the chemistry in the show really is of good quality. Now, you can view the whole 5-6 series of Breaking Bad as like one huge advert for Obamacare, if you like. I mean, where else, apart from in America, would someone with terminal lung cancer have to make drugs to get the money for their treatment? But let's avoid the kind of socio-economic statements about the show, and let's really think about the chemistry and how that happens. So in the show, what Walt does, the main character, is he kind of rolls out in his RV into the boonies to cook some crystal meth. Now, if you're English like me, what that means is he drives out into the desert in his camper van, and within his camper van he makes some crystal meth. So what is crystal meth as a drug? Let's just look at the structure to start with. Well, here it is. This is crystal meth. You can see it has a very typical structure for a psychoactive stimulant drug. Benzene ring on the left-hand side, 2 carbon atoms, and then an amine. All this family of drugs, crystal meth, amphetamines, ecstasy, mephedrone, and so on, they all have that basic structure inherent within them. Crystal meth is a drug that releases dopamine in the brain. You get a huge cascade release of dopamine. That's one of the reasons you feel good when you take it, you feel stimulated. It's also one of the reasons it's very addictive. Dopamine is one of the addiction pathways within your brain. Also, that massive release of dopamine leads to neurotoxicity with long-term use and neural burnout. And there are many problems associated with long-term use of crystal meth that are arising, particularly in America, where the use of crystal meth has been very heavy. Now, I'm going to talk about the synthesis of crystal meth. I'm not going to tell you how to do it step by step, but I'm going to talk about the chemistry of it. And I'm going to give away a few spoilers for seasons 1 and 2 of the show, because it sort of is how the plot gets propelled forwards, is through understanding the synthesis of crystal meth, which is really pretty cool, actually. For a mainstream chemistry show, for a mainstream TV show, to use chemistry to propel its plot forward is really very exciting. Now, the way that Walt starts off making crystal meth is using pseudoephedrine as a starting material. Pseudoephedrine is widely found in over-the-counter cold remedies. It's a decongestant, so it's in things like Sudafed and so on. And if we look at the structure of pseudoephedrine, we can see it's pretty similar to methamphetamine, crystal meth, apart from the fact it has an alcohol group in it. So what we have to do chemically is get rid of the alcohol group. And Walt achieves that using hydroiodic acid and phosphorus. If we look at the synthesis, the hydroiodic acid first of all converts the alcohol into an iodide, and then the reducing conditions remove the iodide and replace it with a hydrogen, leaving you with the structure of crystal meth. Now, there are risks associated with this synthesis. The presence of phosphorus in reducing conditions can give rise to phosphine gas, which is highly toxic, and that's why the characters in Breaking Bad wear respirators while they're cooking their crystal meth using this method, because the risk of poisoning yourself is really very high, and there are people year in, year out in meth labs in America who poison themselves because they do it wrong. But the real problem with using pseudoephedrine as a starting material for making crystal meth is that it's limited in its supply. You've got to go and buy a box of Sudafed from the pharmacy, and they're not going to sell you 1,000 boxes of Sudafed. They're going to sell you 1 or 2, and then you'll go to another pharmacy and another, pick them up, then build up your supplies, then create the meth. And that is time expensive and it prevents you from making a lot of material. And time is something that Walt doesn't have in the show. He's dying of lung cancer. He wants to make a lot of crystal meth and make a lot of money quickly. So chemistry has the solution to that, and this is how the plot gets propelled forwards. Walt realises there are other ways of making crystal meth. You can use an alternative approach, which I'm showing here. This approach uses methylamine and P2P, phenyl 2-propanone. And ultimately, this leads to the creation of crystal meth. Of course, what you need for this is a lot of methylamine and a lot of P2P, but Walt manages to get that. For example, he steals a big 30-gallon drum of methylamine. That's a huge amount of methylamine for cooking crystal meth with. In fact, one of the really interesting things Donna Nelson talks about, who was the chemistry consultant on the show, is they asked her, how much crystal meth could you synthesize from 30 gallons of methylamine? Can you do the mole calculation, the stoichiometry calculation? And what would the street value of that crystal meth be? That was the calculation that propelled the story of Breaking Bad into the big league. Now, let's think about this synthesis, because Walt claims it makes the purest, the best crystal meth that it's possible to make. But it's not quite as simple as that. What happens in the synthesis is you react the methylamine with the P2P, and the curly arrows are showing that process happening. And you make an intermediate compound. That intermediate compound then has to be reduced. And the reducing agent they use in the show is aluminium mercury, or as they call it in America, aluminum mercury. You may wonder why they chose that reducing agent. There are loads of reducing agents you could choose that wouldn't have toxic mercury in. The reason is the actors found it easier to say aluminum mercury than any of the other reducing agents that were suggested. So they went with that reducing agent, although it's not really the best one for the job. Now what that reducing agent does is it adds hydrogen to the molecule in essence. And that hydrogen can add from either side of the molecule. It can add from the top or it can add from the bottom. And that makes two different products. One where the methyl group is coming forwards and the hydrogen is underneath, and one where the methyl group is underneath and the hydrogen is added on the top. Those products are enantiomers. They are mirror images of one another, like my hands are mirror images of one another. And enantiomers have different activities. So with crystal meth, if you make that mixture of enantiomers, the one with the methyl group pointing up is really very active, and the one with the methyl group pointing down is significantly less active. And Walt isn't controlling that in the synthesis. He'll have 50% of one and 50% of the other. Now, a real dealer wanting crystal meth will want the most active enantiomer to get the most active material. So actually Walt's crystal meth is not the most active crystal meth that you could make, but it drives the plot forwards, and the chemistry's right that they're talking about. They're just missing the fact that his synthesis is racemic. It makes the mixture of opposite mirror images. Ideally, he should do the synthesis to just create the right-handed one, the one with the methyl group pointing forwards. And if he did that, he'd probably make even more money out of the drugs he makes. Now, one other thing about Walt's crystal meth, it's blue. Why is it blue? It's one of the biggest questions debated on internet forums. Would crystal meth be blue? No, is the answer. There is no chromophore in crystal meth. There's nothing in the structure of the drug that should absorb visible light. And that means it should be colourless crystals. But the show wanted a signature. They wanted his crystal to look special so that people could recognise it. Heisenberg, which is his dealer name, had to have a trademark. And his trademark was blue crystal meth. Yes, it plays with the chemistry a little bit. No, really pure crystal meth wouldn't be blue. No, you couldn't make a single enantiomer using the route that Walt uses, which would be the most active form of the drug. But fundamentally, the chemistry in this show is really very, very good indeed. It's the fact that the chemistry drives the story forwards, and that the chemistry is believable and basically all accurate, that makes this, for me as a scientist, one of the most interesting shows that I've seen in years. Combine that with the acting, which is some of the best I've seen, I've probably seen shows like The West Wing, and it's up there in my all-time favourite US TV shows. Why don't you give it a go? You'll be addicted in no time.